Hi, welcome to my video on extra problem number 2. This video is similar to the first one, and then I'm going to prove the same identity that I did in the previous video, but this time I'm going to do it using the tan of x over 2 half angle formula is equal to sine x over 1 plus cos x, just to show you that you can use the same algebra skills but on a different formula. And we start with the left side is equal to 2 tan x over 2 and 1 plus tan squared x over 2. And also in doing this video I'm going to do it in 2 parts. I'm going to see the first on this page I'm going to prove it by the fundamental method, and on the next page I'm going to prove it by the LCD method. What I mean by the fundamental method is that when I substitute sine x over 1 plus cos x into the tan of x over 2, then I'll work it by the fundamental method, in that I'll simplify the numerator to 1 fraction, I'll simplify the denominator to 1 fraction, and then I'll multiply by the reciprocal. So here we go. So the right side is sine x. And note, it's from 0 less than or equal to x to 90. So that means that it's going to be a positive. So the tan of x over 2 is equal to sine x all over 1 plus cos x. And there's the division line. And that's 1 plus sine x over 1 plus cos x squared. So to make this, that's a multiplication sign there. So I'm going to simplify the numerator first. So that's 2 sine x over 1 plus cos x. And this is the big line, so let's put that equal sign right in the middle there. And this is a 1, so we got a 1 plus, and sine x over 1 plus cos x squared is sine x over 1 plus cos x, sine x squared over 1 plus cos x squared. So I'm going to use, to make it easier to see and not cram it up, I'm using 4 lines, and this is the main division right here, so that's the same as that one there. And to continue, so we'll go down to here, and the top is already simplified, so that's 2 sine x all over 1 plus cos x. I mean, when I say the top of the fraction is the numerator. So let's simplify the denominator. Remember, the fundamental method is simplify the numerator to 1 fraction and the denominator to 1 fraction. So I'm going to simplify this denominator now. So 1, the denominator is 1 plus cos x squared. So that's 1 plus cos x squared over 1 plus cos x squared, add on sine squared over 1 plus cos x. So what we have, the numerator, again, we didn't do anything with it. We're simplifying the denominator. And there's the big division. So it's 1. We can square this out now. So that's 1 times 1 is 1. And this is a binomial squared. So the product is cos x times 2. So it's 2 cos x. And cos x squared all over the denominator is 1 plus cos x squared. So I'm doing one step at a time and not the big long division. So that's 2 sine x all over 1 plus cos x. And because these two denominators are the same, I will add up right down the denominator, which is 1 plus cos x all squared. And I'll combine these, so it's 1 plus 2 cos x, add on cos squared x plus sine squared x. And this, again, this is the main division. The main division is there. And I'm going to go up to the top now to give myself more space. So this becomes 2 sine x over 1 plus cos x. And there's the big division. So I'm going to add these together. And so I can't, none of these are like terms I can't add, but cos squared plus sine squared is 1. So I have 1 plus 2 cos x plus 1 all over 1 plus cos x. So cos x, cos squared plus sine squared is 1. There it is right there. And again, I'm just doing one step at a time. So I got 2 sine x all over 1 plus cos x. And 1 plus 1 is 2, so it's 2 plus 2 cos x over 1 plus cos x squared. And continue. I got 2 sine x and long division. So now this, I can factor the 2 here. So 2 is factored out as 1 plus cos x over 1 plus cos x squared. Now I have the two fractions simplified. So now I will multiply by the reciprocal. So 2 sine x all over 1 plus cos x. That's the numerator. The denominator I'm going to multiply by the reciprocal. So I turn it upside down. So there it is. So again, dividing by this fraction is multiplied by the reciprocal. And see if we can simplify it. So we have the 2's cancel. We have cos 1 plus cos x and 1 plus cos x. So the 2 of those cancel into this one. So that gives us sine x. And since the left side equals the right side, it is an identity. So that's proving that by the fundamental method. But notice all the steps. It's just tedious to write them all out, but I did one step at a time. Now, what about if I want to do the same identity again using the same formula, but this time I want to do it by the LCD method. And the LCD method is that when I sub this formula into tan x over 2, I'll have a complex fraction. So when I have a complex fraction, I multiply through by the LCD for the numerator and denominator. So let's continue, and we'll do, that's the right side. This is the left side. Just takes time to write all this down. And it's so easy to make an error. So here we go. We'll do a substitution here and put the equal sign, put the long division there. So we got a 2. And the tan of x over 2 is sine x over 1 plus cos x. And we have a 1 plus sine x squared over 1 plus cos x. So it's the same as 1 over s squared, and that's supposed to be there, right there. So ignore that dot right there. It's just, that's 1 plus cos x being, in brackets, being squared. That's not supposed to be there. Now, we want to simplify this by doing it instead of the fundamental way that I did just then. On the other page, let's do it by the LCD method. So the LCD for the numerator is 1 plus cos x. The LCD for the denominator is 1 plus cos x squared. So the LCD for all of it is 1 plus cos x squared. So that's the LCD for both top and bottom. So what I'm going to do now is multiply the numerator by 1 plus cos x squared, and I'm going to multiply the denominator by the same binomial squared. So I'll go 1 plus cos x squared times the 1, and I'll also go 1 plus cos x squared. So I took the LCD and multiplied it by the top and each part of the bottom, so that balances it out. So when I do that, the 1 plus cos x cancels here to get 2 sin x times 1 plus cos x, because when you multiply by the LCD on the top and the bottom, numerator and denominator, all your denominator of each fraction will cancel out. And we're going to do the bottom now. So 1 plus cos x squared times 1 is 1 plus cos x squared. Add on, there's the addition right there. And when we multiply here, the denominator cancels out right here, and we get a sin x being squared. And we continue to simplify this now. So what we have is, because I have to, this is already simplified, I can multiply that through, or I can leave it like that. Let's see, let's just leave that for a second. I could multiply 2 sin x by this, but let's just see what happens. But I gotta simplify the bar. I have to square this out. So this is a binomial squared, so I square the first term, which is 1. I multiply 1 by cos and double it, so it's 2 cos x. And take cos x and square it. That's squaring the binomial. So right now this is following the same pattern as the other one did. Again, I'll just leave that for a second. If I have to multiply 2 sin x by 1 and cos x, I will. So this becomes a 1. So 1 plus 2 cos x. Cos squared plus sin squared is 1. So 2 sin x, 1 plus cos x is the numerator. 1 plus 1 is 2. And so that gives us 2. Leave the numerator alone. And the 2 is a factor, so take the 2 out. I get 2 outside of 1 plus cos x. And when I have that, the 2's cancel. 1 plus cos x cancels. 1, 1, 1, 1. So that gives us sin x. So since left side equals right side, it is an identity. So again, I did, using this formula, the previous page, I did it by the fundamental method, which was simplify the numerator to 1 fraction, denominator to 1 fraction, multiplied by the reciprocal. Because I have a complex fraction Here, same as before. Another way is to multiply the top and the bottom by the LCD, and the denominators will cancel to make it a little bit easier. But that is your choice when you do math. Which way do you go? Again, when I have complex fractions, I think of multiplying by the LCD. It makes it a little bit faster. That brings us to the end of the video, and if you like my video, click the like button, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content that's on my YouTube channel called Math Fully Explained, which is just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.